Friends, welcome to the 9th lecture in module 3, where we are going to extend the discussion what we had in the last lecture about SHM design and its suitability to offshore structures. Okay? We are going to discuss about that. First, let us see what are the components of SHM design. Structural health monitoring system as applicable to any kind of structure, but our focus is related to offshore platforms, okay, at this moment. So, the hardware component of structural health monitoring system consists of 4 functional modules. One refers to sensor unit, second module refers to data acquisition unit, third module refers to computational core, and fourth module refers to wireless communication channel. So, there are 4 modules which are going to design. We are going to see the characteristic of the design of these 4 modules, which is now going to emerge to a SHM system which can be applied to offshore platforms. Okay. So, the most important commonness between these modules . One, in all the modules we are going to use commercially available hardware components. Okay. The idea is not to make it custom design, but commercially available hardware components will be used. That is the first condition we have. So, the technical details of these components will be examined for its versatility, availability and cost. I mean, we are looking for different sub conditions which need to be satisfied, okay, of the HSM design of the structural health monitoring design is that a layout of sensors costing lesser and functionally efficient. Okay? That is the objective. The components of structural health monitoring system into 4 basic modules, which comprises of sensor unit, data acquisition, computational core, and communication channel. Consists of 4 modules. Okay? Just now we saw that. Because we need to measure the deck acceleration of the platform, we need to measure the strain to check the feasibility of permanent deformation in the material. We need to also measure the temperature variation, because sometimes the fire sensors can also be used to raise an alarm of prospective fire in the platform. temperature sensor. We need to measure rotations. So, we need inclinometers. To measure rotation. I mean, of course, the pressure sensors to measure the stress. So, all this will comprise in the sensing unit. Control interface, analog digital converter units, signal conditioning units, filters and amplifiers. The computational core, microprocessor, signal processing algorithm, and the communication channel consists of two things. One could be for the wired, one could be for the wireless. For the wired, we will have twisted pair of wires, we will have coaxial cable, and we will have also optical fibers. As far as wireless system is concerned, we will go for radio frequency modules with wireless protocol, we will also enable satellite communication. Okay. Now, let us talk about each one of the modules separately. Let us start with the sensing unit. Of SHM design. Sensor based structural health monitoring system measure two quantities. One is kinematic quantities like acceleration, inclination, strain and displacement. The second will be environmental quantities like temperature, humidity, wind direction and speed, etc. Wireless sensors are proposed to monitor both kind of quantities. Wireless sensors are supposed to monitor both types of quantities. It also enforces level of monitoring. Why this is important in this case? Now, offshore structures are massive. So, we want to ensure up to what level monitoring need to be done. In sense, up to what extent measurements ought to be taken. This is to be pre-decided. Okay. Now, as we all agree, sensor technology has advanced very forward. Or very rapid and smart sensing units. So, one can use a combination of these based upon certain basic criteria. What is the basic criteria which we must check before we do select these type of sensors? 1, we should check for the capability to capture both local and system level responses. This is what we check as extent of measurement. Second is capability to capture or to acquire data in both consistent and retrievable manner for long term data processing and analysis. Thirdly, we have to check the adaptability to operational conditions and the hostile environment posed by the. With all that, we have a prerequisite. We must choose sensors that are commercially available in the market. So that the cost can be brought down if the production is massive. Okay? That is the idea. So, we need to match two cases: 1, the sensing requirements; 2, the instrumentation capability.